Today we will talk about custom code in Pinball, or like custom Python code in MPF or in Pinball, like in MPF. I mean, we want to conquer the world, but let's start small. And I prepared a small agenda. That's this one. So first, I will like shortly cover like the philosophy of MPF. So why are we doing certain stuff in a certain way? Then like config versus code. Why do we do stuff in config, and why don't we do everything in code, for example? I guess that's a valid question. And then like more like on the practical stuff. So how do you extend MPF, on when to use code and when maybe not? And then at the end we will look into MPF itself and how this actually works. So how do you build like custom code or modes with custom code and all the other fun stuff? I guess not everybody would call it fun, but I do because I like coding. So yeah, that's our agenda for today. And so we will just jump into it. So what is like the philosophy of MPF? So why is the framework the way it is? So because like there's a distinction between like a library and a framework. So library is something which is like which you call in code basically. So it's something you use actively, but you basically build the glue. So that's on you. And the framework is usually a little bit more like there you got like custom language. So kind of like the MPF configuration is a custom language. Like a DSL, a domain specific language is how you call it in computer science. And that's what we're running. And that basically requires that you provide the tools to use your language, kind of, right? But we basically go the framework way. So we're not basically a library, we are a framework. And with all the drawbacks that has, but what we try to do is like we want to basically provide reusable building blocks. So pinball machines are like 90% the same, and like the 10% which is different, that's where the fun is. And we want you to like focus on the fun part, not on like the boring part which has to be repeated every time, right? And that's basically the philosophy. So we want to have a low barrier for entry, especially for non-programmer types. So we know that like we programmers, we feel special and we say, yeah, we know how programming works and it's super easy to program a pinball. And that's maybe true. But also if I wrote a pinball, it probably wouldn't be that much fun because I'm not like the creative game designer type. And like creative game designers often struggle with coding. So like there are exceptions like everywhere where people know coding and are great designers, but usually those types of people do not match too much. So we also focus like on the designer type of humans. And so for that reason, we want to have a low barrier of entry and like also like a high abstraction level. So like you shouldn't have to care about which hardware you have when you design a game. That's something you can take care about later in your life cycle. So you can basically build a game and later choose your hardware and then with like minimal changes run your game on any hardware. And that's also like useful in like a development life cycle. But also like we want the framework to be extensible and like flexible. So maybe we did something in a way which doesn't fit for you, and then we want you to be able to extend it. Maybe that's then not so much a designer activity. At some point you need like a programmer, but that's like a small part where you then extend the framework. And I will like show you the extension points later where this is possible and how this is possible. And we will look into this in the demo. So basically MPF is here to help you, and we want to make it as easy as possible for you. That's our goal. Yeah. So config versus code. So like you could say, well, MPF is super special because it is this YAML stuff and nobody else does it this way. But that's actually not true. So if you look at like major AAA games, I don't know, like a lot of shooters, for example, like I don't know what is modern. I don't know, to be honest. But like any modern game, they run like Unreal Engine or Unity or something. And basically MPF is like it's like your game engine. It's like Unity. You choose Unity because like it got 90% of what you need. And all you need to do is basically build the level, build the weapons if you build a shooter, and then you're done. Then your game is basically done, right? So you provide the content for the game, and that's like a large part of what you do in those game engines. And then the question is like, so what do you do if the level editor does not have that feature you need? And usually that's where you then start programming, and that's also something you do in Unity. And often ways like those game engines, they got some kind of either like configuration format for levels, for how you import meshes for like persons and for weapons and items, and they got a lot of support structure around that. And if you like read game design books, that's what they recommend. So build like a configuration format where your designers design your items in your game, and then as a programmer focus on the hard stuff, which is like in games rendering beautiful 3D stuff and like making it performant and so on. And that's basically also like the approach we take in MPF here. So MPF drives your game and does the boring stuff from a designer perspective and the fun part from a programmer perspective. And like the configuration is the interface between those two. And so that's our take on that in general. So like use configuration, and even if you build your own abstractions, think about if you want to make it configurable. So like then, especially if you got some job split in your Pinball design team, then it might be useful to create your own config elements. That's totally possible in MPF. And then have it configured by your designers, and then they can change values and so on. So that's my take on that. And there might be different philosophies, but that's my philosophy here. So now, like, let's say you hit some corner case where MPF did not or does not yet support your use case. So there you got like a few options. That's basically fourfold. So I see like 4 things where you would, or where you could extend MPF. That's first, it's custom mode code. So that's the most common stuff. So basically you write a mode with like some special logic. And that can be anything. So that can be like logic, that can be stuff which drives hardware, that can also live in a mode. It can also like special display stuff, that can be a lot of stuff. Then you can, like modes, they can be loaded and unloaded, right? And that's sometimes useful because you do not want to have them active all the time. They can access player variable and do player specific stuff. So that's custom mode code. Then we got something which is called custom code in MPF, or custom code blocks. They have been called scriptlets earlier, but we renamed them to custom code. And that's basically code which is started at MPF startup time. So there you have to take a little bit more effort to hook into the game, right? It's just started in the beginning, and then you can, for example, add event handlers for game start, and then you can do stuff in the game. But it's more for general stuff. So if you want to have like some easy hardware edition where you display stuff, that would be something which you could put in custom code blocks. Then you can also have like your custom devices. A device is something like a counter, or also like a ball device. That's all devices. And you can have custom devices if you need something which is reusable. So if you got some special logic block which you need like in multiple modes, you can put it into a device, and then your designer friend can use it in all his modes, for example. That would be something. And then like you can also like have custom hardware platforms if you want to run like your own hardware. So if you're a pinball startup and say, well, I want to build my own board set, I run my own protocol and so on, that's also totally possible. And then you can have a custom hardware platform. I did like a stream on that like a few weeks back. That's also possible. So then like when should you use custom code? And that's generally, I see like also like 3 or 4 different avenues where you would do this. The first is like if you got new or different hardware, then you either reuse one of our protocols or implement a new hardware platform. That's I guess obvious. But also like if you got, I don't know, for example, you got some Arduino somewhere which drives some additional lights or something, that would also be something which you would typically do in custom code. You might want to do this in a scriptlet, but you could also run a custom hardware platform. That both is possible. And then if you got like different game flow in general. So I mean our framework is very much focused on like the typical game where you hit start, then the first player is up, one ball, and then you add a second player. First player drains the ball, second player is up, then first player again, and so on. So back and forth. So if you want to change that like structure, like if you say, well, I don't know, the first player should play all his balls and then the second player plays all his balls. If you want to do something like that, that's not something we support out of the box, and that would be very hard to impossible to do in like configuration. Then you should like run custom code. Also like for those stuff where you, I don't know, where you start to count balls differently and so on. So for example, if you got a head-to-head pinball machine like my machine, where like you count 2 ball, basically you count balls per side, and that's basically a different type of counting, right? Then at some point you want like custom code for that. Also like if you want to do manual ball management, so sometimes you want to stage balls to certain positions. I don't know, for like if you got a shooter cannon somewhere and you want to stage a ball in the beginning, that's not totally impossible in configuration. But if you want fine-grained control, like then I would run custom code. I also do this in my machine, so where I stage balls on different places in the playfield so that I can feed balls faster into play. Because in a head-to-head machine you want to have fast gameplay. So that's something which you would want to do. Or if you have like some very special mech where you have like a ball lock and you want to refeed it on the second player if the first player drained it and stuff like that. At some point you want custom code. And in general, like any special logic, like if you got like certain logic with your toys, which is not easily expressible in a state machine, a lot of stuff is possible in state machines, but at some point you might also just run code. Especially if you got stuff where you, for example, you got like 200 LEDs and you want to light them up depending on a certain number. You can do this with shows in MPF. That's possible, but it's much easier with just 3 lines of code to turn a number into a number of LEDs. That kind of stuff is sometimes easier in code. It's always a trade-off, but that's my take on when you should use it. And I will also show you later what I did in my machine in custom code. It's not very much, but there's a few places where I actually use those hooks. Yeah, that's basically from the talking part now. I mean, I will keep talking, but from the talking with slides part. And now we will jump into code. And if you have any questions now, feel free to ask. Basically any time. But now would be good point for the theoretical part, and otherwise, yeah, you can also ask later. Yeah, so let's go into my machine. So this is my small machine. Let's start it. And what we will do now is we will implement a custom mode code. So if you want to have custom code in your mode, first thing you have to do is usual, register your mode. That's standard stuff. Then, but it's often this thing you forget, and then you're wondering why it's not working. Happens to me every second time. And then you define your modes, inside your modes folder. You got the mode name, and then you got usually the config folder where you got mymode.yaml. Has some start events, could be on ball started, for example, and stop event, sometimes not. And this is optional. I run a non-game mode now, so it runs outside of a game. It's for easier testing. And then you define where it should load the code from. So that's basically a full Python path. So anything which your Python interpreter can load will work here. And sounds scary, but it's basically relatively simple. So it's modes, that's the folder here, then the mode name, my mode, then code, that's the folder again, and then my mode, that's again the file name, so you could also name that differently if you want, and .py, right, and that's just the name. And then if you look into this file, we see the class which is called my mode, and my mode is then basically the last thing in this path. And if I would rename this class, then I would also just rename it here. And this way, basically, that's how Python imports stuff. And it's very flexible. It doesn't have to be inside your machine, for example. It could be like an external module if you want. I wouldn't recommend it, but it would be possible. So that's already basically how you tell MPF to load custom code. So yeah, that's as easy as it is. And then we implement the mode. That now it gets funny, or now the fun starts. So I choose a standard mode. So you import the mode from the mode base class from MPF. Your IDE, most IDEs can autocomplete it. Vscode cannot, but if you use Pycharm, it will autocomplete this. And there you got a few methods you typically want to implement. First is init. Init is basically, that's when this class is loaded. And that's basically on machine load. So that's not when MPF, that's not when the mode is started, right? It's when MPF loads the mode. That's when MPF starts up. That's just to keep in mind, because that's easy to confuse. And then we got mode started and mode stopped. That's, the name is, yes, it's obviously when the mode starts and when the mode is stopped, for example. So Chris wanted to know, I've noticed that you don't need to specify the mode name. I assume this is optional. Like here, no, here you do not have to put the mode name. That's optional, right? Yeah, you do not need that. Also, the class does not have to know how the mode is called. It doesn't actually care. And so what I did here is basically I just print mode loaded, mode started, mode stopped. Very simple. My mode starts on test event 1. That's basically bound to my keyword E1 and 2. So we can just now use this machine. I will show you the log. And now we can first scroll up a little bit and see, scroll up a lot. And we should somewhere find my log message where it actually has been loaded. Yeah, I thought I would see it, but there it is. Yeah. So basically that's in the beginning when MPF starts up. So you see the init phase 1, that's very early in the machine. So this is basically when MPF loaded the mode. And now we can scroll down, can press enter a little bit. And now I press 1 in this machine. And now you see that this mode started. And you also see the log line mode started. And now if I stop it, actually the same will happen. So that's very simple, right? So we have a mode, it can start, it can stop. It's as simple as that. So now it does nothing. And we want to change that. So what can we do in a mode? So not much, to be honest. So what can we do? We can do like self. So what we typically want to do is like we access the machine, and that's found in self machine. That's the reference to the machine, the MPF machine. And inside this machine, you got stuff like switches, and then you can access a certain switch, for example. So for example, in my machine, we got like S door open. So that's that switch. So for example, we could access this switch, and then we can, for example, access the active, like if the switch is active or not. That would be something. But usually that's not what you do. So what you usually do is self machine events add handler. And then you add an event handler. That's the most common stuff you want to do. So for some event, for example, test event 3, we want to have an event handler, and we just define an event handler, my handler, and now we can handler called, and now we just have to give it self my handler, and that should theoretically register this handler, and this handler should print this message. Right? Let's see. This actually works. This one, and it crashed. Ah, yeah, the switch doesn't have an active. Okay. I guess it's called state. I think it's called state. Yeah. So now the mode started, and now we got this event handler on test event 3. Test event 3 is bound to my 3 key. Let's press it. And now you can see that like handler called is printed here. So that actually worked. So this is the first thing you usually want to do. And you do this quite often. The second one you often do is like you want to trigger something in like 5 seconds, for example. And that way, that's done usually using like delay manager. And so there are different ways to do this. But one is like a delay manager. That's basically a built-in like helper. I call it helper, which will call you back. And so, for example, we can say on my handler, which when I press 3, the handler's called, and now we want to have a delay in like let's say 3 seconds. So first is like milliseconds, and then the callback. So like let's say 5,000 milliseconds, and then we call like my handler 2. I have to give it more. No, I don't think so. And def my handler 2. So let's see, it works. So now it should be like it first should call this handler again. So start the mode, press this, press 3, handler called, and now handler 2 called. It took like 5 seconds. We can do it again. Handler called, and like after a few seconds, handler 2 called. So that works. So now what happens if I stop the mode? It's a trick question. I will show you. Mode stopped, right? You see it. if I press 3, ooh, still happens. Handler called. And now you understand why code sometimes gets tricky. So what happened here? So we use like the machine to register an event. We never like removed the event. So what we can do is like we can now go into like the stop method, and we can remove the event handler. I think it's like it works this way. Remove handler. Let's see. This works. So, and now we can press 3 and nothing happens. How it should be. Press 1 again, press 3, and that's called. Stop the mode, and even now, like, the callback should happen. Yeah. So, no, the delay did not trigger. So because delays are automatically cleared at the moment right here. So like the delay didn't trigger. So this obviously isn't fun. And for that reason, there's also like a helper which is called add_mode_event_handler. And the only difference between the two is like add_mode_event_handlers, they can be called exactly the same time, same way. They are automatically cleaned up when the mode is stopped. So we can now remove this line, and now we can start the mode. Now we start the mode of the machine. Press like 3, event is called, and after 5 seconds the handler 2 is called. And now we can stop the mode, press 3, nothing happens. And that's basically like the core abstractions of like custom code and modes. Yeah, that's basically the most, I would guess, the most common stuff you would be doing. And then you can run any arbitrary Python code. If you know that, you know like 95% of what you need to know. Now you've seen that like this coding here, that hasn't been so much fun, because like autocomplete does work for some stuff, but not for everything here. So for this it works, but for the machine stuff it didn't. And that's because it's Vscode, and I personally usually use like the Pycharm for exactly that reason, because that is a little bit better than Vscode on autocompletion and so on. So let's look into that a little bit. So for example, if we look at custom code in my machine, I got one mode which is called ball balance, and that is used to, so basically my head-to-head machine has 2 troughs at one side of the machine, both sides of the machine there's a trough, and sometimes too many balls make it to one of the sides, and then I shoot them over and basically rebalance the troughs. And I got some feeder devices on the playfield, and I also like pre-feed or stage balls into those feeders, and that's done in this machine, in this mode. And as you can see, it looks very different, very much the same, not different. Just the background color of this IDE is white instead of black. Yeah, you can see that I access a few ball devices here. In this case, like if we look at like this variable, the IDE knows what it is, so it should be able to autocomplete this. For example, it knows that the ball device has available balls, name, config, and so on. So it knows exactly not exactly, but very, very well how this code looks, is structured internally, right? So it can look into MPF and can look up stuff for you. That's very useful. And besides that, I use like mode event handlers. It's nothing special. I check some if there are balls, if there's sufficient balls. Otherwise, I do nothing. And then like I call methods like request ball, that's to stage a ball into that device, and so on. And I got some handlers here for different stuff. You can look at the event reference in the MPF documentation, which events exist. For example, like the strain events, or events when the ball device successfully ejected a ball, and you can bind on that. And nothing too crazy here. But you can see there's nothing like which is a lot different than what I just showed you. So that's basically how code looks like in a mode. Then I can also show you like scriptlets, custom code sections. I got one which just does one thing. So I got on my slingshots, I got like those LED bars, like it's serial LEDs. I think it's 8 per slingshot, and I got like 2 slingshots on every side, and I used them to display how many lives the other player has left on the one side and my own lives on the other side. And that's basically something I do in code because that's just a little bit easier. And I basically got event handlers on the machine, or like no, it's player variables and 2 player variables, lives front and balls front, lives back and balls back. And when those change, I update my LEDs. I calculate like which color they should have and how many of them should be on. And then I just set the color on the light. So the light is basically the device, the light device which you defined in configuration. And then I call like the color method on it. And now you can also like press Control and go into the definition. So you can check out the code of the light device, for example. So this IDE is pretty nice. It understands Python really, really well. So that's basically what this is. And now I also got one thing more. Yeah, right. I got custom devices in my machine, and that's I guess that's not super common, but it's possible. So as my machine is like a head-to-head machine, for multi-balls, it doesn't matter where they drain. So like a normal multi-ball, when a ball drains, doesn't matter where, it reduces like the multi-ball count by 1 or triggers shoot again, depending on if the shoot again is still active or not. In a head-to-head machine, it's different. So a multi-ball, if it drains on the other side, that will not reduce like the multi-ball count on my side. And for that reason, like I got my custom multi-ball and my custom ball save devices. That's basically mostly like a copy from the MPF multi-ball. And that's basically also something you can do. You can copy some device from MPF if you want, modify it whatever way you want, and then even have like some custom configuration specification. That's basically, it describes how it's configured. So that's basically what can be used in configuration. And then that's a little bit more magic. So there you should like read a little bit of MPF code to understand it, but I just wanted to show you that it's possible. And then in my configuration, I actually just add those devices here. That's the way you register like your devices to custom devices. Again, this is like a normal Python import path, so anything can go there. It just loads the code from that path. And the same is valid for like scriptlets. That's just looks like this. So you just give it the code path and it will load those scriptlets or the code from there. And that's how you register this in general. Genau, exactly. So I got multi-ball, I got a ball save, same reason, because like ball save is for my playfield and not for all playfields in the machine. So code is a little bit different. So roughly this is how this looks in my machine, and we wrote a little bit of code. I got one more thing, which is like a little bit advanced, but I wanted to show you anyway. So you can also use like Python Async IO. So what's Python Async IO? That's like where you can write like a coroutine. That sounds scary, and I mean, no, it isn't. It's not scary, but what it does, it basically runs in parallel. So it's not a different thread, but it runs your code until you yield control. And then like MPF will continue until some of your futures, you register futures on stuff, and until your future will basically wake up your coroutine. Sounds a little bit scarier now, but I'll show you anyway. So that's why I imported this async mode, and MPF basically has a different base class for this, and it looks a little bit different. So for that, you typically just implement the, I think it's called run, and it's called async def. So basically, it's an asynchronous method, which is like a coroutine. And what you typically do in those is a little bit tricky. You typically do like while true, and in normal code that would basically block your control. In general, like in MPF, never block control, because MPF is running like in one thread, and if you block in your code, you will block MPF, and nothing else will happen. No switch events will occur, no coils will be pulsed, nothing. So usually do not do that. In Async.io, it looks like you're doing this like in a sequential program without like all those handlers which fan out, which is sometimes tricky to follow this logic. So instead you do something like this. And this, I mean, it looks weird, right? At least if you look at other MPF code, it looks weird. So what we can do is we can print like hello world, for example. And now it would like endlessly print hello world. That would be bad. But what we then could do is like we do a wait. That's basically where we yield control on async.io sleep. Like let's say we sleep 1 second. And now we need to import async.io. And what this would do is it print hello world and sleeps for 1 second. And it looks like sequential code. That's super nice for a lot of logic. We can try this, and now this does not run. The mode isn't started yet, but we can start it, and now it should like give hello world, and so on. That's run asynchronously in parallel to MPF, as you can see. We can also like stop the mode, and this will stop. So even though it looks like a loop, it's very, very simple. And what we also can do is stuff like we can wait on self-machine events. That's that with Vscode. Let's check here. That's like wait for event exactly. So we can do like wait for event, test event 3. And now we basically print hello world. We remove this line. We print hello world, and then we wait until this event happens. Let's do it. Let's try it. Start the mode. It printed hello world here. And now I press 3 for the other event, and it prints hello world again. And I can do this again and again, right? And very, very simple. And we can also do stuff like, I don't know, let's say we got some counter, we set it to 0, and now we say counter +1, and we can also print our counter here. So now we will basically count events. I guess you see where I'm going. So like 3, 4, 5 here, right? 6, 7, and so on. Stop it, and if we start it again, it will start at 1 again, right? So, or at 0. So that's something you can do with Async.io. You can also like encode post events. It's like self machine events, and then post let's just post and hello world, we can say, and now we can also give it like a parameter, counter equals counter. So we will basically append the counter value. So one hello world, and we should also, yeah, here we got like an event hello world, which value is value 1, here 2, so on, right? And with that I can also like interact with other logic in MPF. So for example, if I got a state machine, I can post an event from custom code, state machine would advance, and then the state machine can later post an event, and I got an event handler and wait on the state machine, for example. So this is basically what I can do. Obviously, I can also do stuff like pull some coils, so self machine coils, and then I would like coil, eject here, and give it, for example, pulse. And it would pulse this coil. Let's see if it works, but I think so. Now we can see here, pulsing driver for 10 milliseconds, and again. So this kind of stuff that's available in custom code, and as you can imagine, everything is possible. So that's basically what I prepared. So if you got questions or if you want me to try anything or show anything, let me know. Yeah, for me, like I do this all the time, so I know what this is. So and yeah, so what are some strategies on code to be called across modes? How would you create a shared method to use in any mode? That's in Python, that's relatively easy, I would say, because you can like import stuff here, and this import is basically in any folder. So for example, I could even like import another mode, that's possible, but in this case, for example, I can also like have custom folder in my machine here, new folder, let's call it like, I don't want it there, I want it at root here. I struggled with this last time. How do I create a folder inside my I will do it like in the CLI, make the code. So now we got like some code directory somewhere here, and inside this directory you can give it any name. We can, for example, call it sharedcode.py. And now we can put like either classes or just methods. So we can, for example, put like a shared def shared method counter, and now we print hello world counter. That's what I had. Hello shared world. And now we got like code. That's basically the module path, and the file is shared code. And we can, so usually your IDE will also autocomplete this, but Vscode probably will not. Let's see. Code. It won't. So we import like code, shared code, and then from that we import star, so everything, right? So we would import everything, or we could also import this method. And then now we got a shared method imported, and we can also like call it here. That would be the way to import, for example, the shared method, which is imported from code. No name shared code, but I think it should be there. Let's try if MPF lets me do that. No, it crashed. So it has been like modes, my mode code. That folder. I would have guessed that this works. Shared code method. We can also we can definitely put this in a mode. So we could also have this in my mode, and then it would be like modes. It would be this path basically. The shared method. Shared code. At least Vscode does not. It does complain. Let's see if this works. No, not yet. So modes, my code. No module modes, my code. Code. Let me see. That's definitely possible. Like if you just need to see how the import path works. So maybe I used it somewhere here. Maybe not. So usually that maybe we need actually an init file into this folder. I didn't use it actually. So maybe. So we could definitely do this because that's possible, right? That should work. Let's see. Not even that works. Did I save it? That should be possible, definitely. No module named shared code. That's yeah, probably. Maybe we need. So theoretically, you do not need those init files anymore, but sometimes you do need them. And I'm not always sure why you sometimes need them. But then you need those initpy methods. But I can look this up later otherwise. Yeah, the shared code does not have to be in a class, so you can also import methods in like not in MPF, but in Python in general. So it what does it do here? Modes, code, yeah, that's actually what we're loading. So for some reason, so shared code py. So what you can always try in the console. So import modes, my mode code, shared code. That works. And now we can do shared code dot shared method test. Name shared code is not defined. I have to put it this way. Yeah, now it works. So the import definitely works. So from import shared method. So now I can call it. So like Python knows to import it. And this should also be like this line should also like work in the mode. Maybe I had a typo earlier. I'm not sure. Yeah, that looks good. So 1 and 3, and now we can see hello shared world 1, 2, 3, and so on, right? So that's actually how this works. And now you can like import this line in any mode. So like you can also have the same like import statement in any other mode. But it should also like work from this code folder. Now why? Let's see. Maybe I need to put an init py. Sometimes, I mean, theoretically this shouldn't be needed anymore, but sometimes it doesn't work without those init.py files. To be honest, I don't fully understand it. So now it would be like this. Let's see if this also works. Yeah, it also works. And so yeah, that's actually what I initially wanted, right? So now, yeah, you see those hello shared world. That also works. You can also like put a class here and import that class and call methods on the class and anything which is possible in Python. So this would be, for example, one way to share code between two modes. Yeah, so anything else you want to see, or yeah, showed some debugging techniques. Do you have any other tips to help with troubleshooting? I mean, sometimes if it's not loading, as what I just showed, it's a good idea to like run the Python CLI. So like you just like inside your machine folder, type Python 3, and then you got like an interactive CLI, and you can resolve all those import errors. Especially like if you got a syntax error, it will tell you on import. Otherwise in MPF it might be like hidden in a stack trace which is 10 meters long. So that's sometimes useful. Also, sometimes it's useful just to call the methods here, right? And then like for testing, just put some key bindings and have an event handler which just registered to your event. And like I did a stream on like unit testing. You can also unit test your custom code, and I highly recommend you to do, because that's something which like might break if you update MPF, for example. So one of the downsides of code is that like the API of this async mode or mode might change. Usually it's then it's like there's a new parameter to your method or something. Usually it's not much, but like stuff in MPF might change, right? So like the pulse parameters on the coil here, that might change, for example. So it's very useful to test your code. And that's also like kind of the drawback. Like for configuration, we try to make sure that stuff which worked in configuration keeps working. I mean, there are limits. If like it's used like in a special way, sometimes we change like configuration in incompatible ways, but we try not to. But with code, that might happen more often. So for example, for my custom devices in my machine, on any major MPF update, I have to like change some method signatures or something, because then something in MPF got refactored, and yeah, my devices did not get refactored, right? And that's like the beauty of MPF. So we do it in the background, and typically you won't notice, and it just gets better for you. And with custom code, you have to do what do we do on the MPF code. So like so you can write everything in code, right? So especially like with this, it's super nice, and it's a lot of fun to write logic this way. But then like it's not that maintainable in some cases, right? So like with like a state machine, you got like debugging tools in MPF and so on. You could also use breakpoints here, but like if you put a breakpoint here, it will basically stop your whole machine. So I would only run it like virtually. So like in Pycharm, you can, for example, then like at a breakpoint here, and then like run MPF in debugging mode, and then yeah, it will stop here, and you can see all the variable values and so on. That's also often very useful. Otherwise, as you've seen, I often refer to like print. It's useful, it's helpful, and you can print anything. There's also like pretty print, pprint, that will like print objects like in a nicer way. Sometimes that's useful if you want to print a lot of stuff, but it's like general Python debugging, right? So anything which is possible in Python is also possible in MPF. It's a standard Python class. It's nothing very special. So you can call anything in MPF with it, and there's also in modes, there's like self-log, so you can have like debug logging, info logging, warning logging, or like also error logging. That's like useful for production code, so then you can later silence the logging. And that's probably, yeah, that's like for polishing your code, right? But besides that, yeah, what else? And with custom code, are there certain things that people should generally stay away from, things that are not recommended? Yeah, blocking the machine. Do not do it. I mean, it might work in test, but you will, for example, lose switch events if you block the machine for like 100 milliseconds. That's a bad idea. So one thing you can do is, for example, use a serial. That's very common if you want to talk to an Arduino. But you have to be aware that PySerial will actually block if you write too fast. So like if you write like 10 bytes a time and you write like 1 time a second, that won't matter, right? Because there's a buffer in your operating system. This will not practically block. It might, but it's very unlikely. But if you write a lot of data, then actually this write call might block. So be a little bit careful with serials. And if you like want to read serials, then use like the Async.io version of it. So like that's PySerial Async.io. It's also what we used in our MPF platform. If you want to do time sleep, don't. It's a bad idea. It's always a bad idea. Anything which can block, and sometimes even stuff in the background may block. So for example, if you do like an HTTP request, it's not per se a problem. But for example, DNS might block, and like an HTTP request might also block. There are like Async.io versions of all those libraries. It's better to use those, and Python has a major like ecosystem for all those stuff in non-blocking. If you really want to do like CPU intense stuff, which you probably don't in MPF, but if you want to do that, or if you really want to block like on a serial because you think it's easier to write it blocking, which is fine in some cases, then spawn a new thread or a new process. That's both possible in Python. You can have thread or process. In a thread, be careful with the global interpreter lock. That way, that's basically the interpreter has one lock if you to access all objects. And if you block in native Python code, it might still block everything. So if you're unsure, you use a different process. If you run a different thread, just be a little bit careful. But you will notice when MPF gets slow suddenly. That's actually what will happen, right? So do not block, and do not like run like very CPU intense stuff in your modes. But I mean, MPF is like the logic side. It's game logic, not usually not processing much. That's what you would do in MC, and in the media controller, yeah, just be fast enough, but you can block there. That's basically, yeah, it will give you a lag in the media controller, but usually it's not that bad. You can do it on the media controller side. You can, yeah, that's something I didn't tell earlier. You can also like run custom code in the media controller, right? So you can have custom code in MPF and in the media controller. If you want to have custom shader, custom effects, like mini games, you can write this in the media controller. You can have code in a media controller. It's also something some people did actually. So last questions. You originally showed an event handler callback that needed to be manually unregistered. I'm trying to figure out what scenarios this would be more useful than using add mode event handler. So internally, like add mode event handler does exactly what I showed before. That's only useful if you want like an event handler which stays active. There's some cases, for example, if you register like a drain handler, so a handler which is called on draining balls. Sometimes you got like a mode, and after the mode ends, you want like, for example, a multi-ball mode with like custom multi-ball logic, and you want like you want to prevent those balls from ending the game. And then you add like a handler and handle those balls, and then this handler unregisters itself. That would be like a use case where you would you would not use like a mode event handler. But like that's more like for all those special stuff like relay events, queue events, and stuff like that. But normally, add mode event handler is always what you want. That's you will know when it's not the right choice, or you will quickly find out that it's not the right choice. So generally, I recommend to use that. Yeah, we reached like the magical 1 hour where we end the questions. Now, if anybody else has a question, feel free to ask. I will be around. So, and if not, that's also like fine. So, yeah, then thanks guys for joining in. And if you got more questions like tomorrow or somewhere, like feel free to ask in the forum. There are a lot of different ways to do custom code. That's just like the beginning of a whole journey. And so yeah, just try it. It's actually fun. It might break your machine in creative ways, but it's fun. You will learn a lot about the internals of MPF. And something to remember is like, if you extend something, you can also like extend the built-in modes and so on. Didn't show this here today, but that's I think I showed this in like in a service mode stream. But that's also something you can do. You can like extend an existing mode, like one of the 5 built-in modes in MPF. And if you do this, consider like upstreaming it, right? So if you build like a device and you say it's super cool and everybody wants this, and like they are more than just my machine, which has this kind of, or which needs this kind of logic. If you got like something for EM machines or solid state machines, then yeah, just send a pull request or just send the code in a forum or send me an email. There are a lot of ways to upstream code, but a lot of useful features in MPF actually were created like this way. So somebody needed it, often they created in custom code, and then we upstreamed it. And then we maintain it for you for free. So consider it. Yeah, and that's basically what I want to close with basically. So consider upstreaming, and keep experimenting, keep building Pinball, and yeah, have fun while doing it. We are most of us are not getting paid for building Pinball. A few lucky ones are, but most of us are not. So have fun and yeah, keep building Pinball. And until then, I wish you like a nice remaining week. And I will be back on Saturday. I will probably talk about light display player. And so how do you map like your playfield on how you use your playfield as a display basically, and with like dynamically generated stuff. So I will show that. Will be a lot of lights, and it will be beautiful and colorful and hopefully fun. Yeah, until then, have a great evening and see you around in one of the many forums. I'm out.